Our last section before the test, 3.11, differentials. It starts on page 201, but the notes actually begin on page 204. Now, you could, just to give you an overview of this section, you could divide this section into two parts. They're the problems where you use a given formula. And then there are problems where you have to remember the formula, or maybe geometry, or algebra, or somewhere like area of a circle, circumference of a circle, things like that where they may not come out and tell you, but you've had it, it's just been a while. So to me, the problems where they give you the formula are the easiest kind. And the problems where you have to remember it are a little more complicated because you're wondering, well, am I using the correct formula, or should I be using something else? But first, there are a lot of definitions, a lot of notes in this lesson. An increment in a variable is the final value minus the initial value. Now, we're used to that a lot in math because just the slope formula, isn't it y2 minus y1? So that's a final value, a final y minus an initial y. Or the denominator is that way too. It's an x2 minus an x1, final x minus an initial x. So that's what an increment is. The way you write an increment in calculus is delta and then whatever the variable is. Now really mine looked like a triangle, but the book has a nice beautiful Greek letter delta with all the nice shadings, and it looks just like the delta, from the book. It looks much better than what I've written up here. But delta and x are together. That's one entity. It doesn't mean delta times x, I'm going to divide by x and get delta by itself. We can't do that. It's together. Delta y, delta t may be a change in temperature. Go outside and the temperature's 90 degrees. Come inside, the temperature's 70 degrees. 90 minus 70 is 20 degrees. So the delta t, the change in the temperature, is 20 degrees Fahrenheit. It's an example of a delta value maybe in chemistry or physics. Delta theta, a change in the angle theta. So that means delta, and it just means a change. If you had a chemistry class where you did a lab and maybe you had to find the change in pressure or the change in temperature, then your lab book probably called it a delta something. Or if you're taking that class later, you'll see that later. Now, differentials sounds kind of like the word derivative that we've studied throughout Chapter 3. And they're similar, but they're different. dy by itself, not dy over dx, just dy, is a differential. And it means the change in y that occurs as we begin at x and travel along the tangent line until we have moved dx or delta x units. dx just by itself, not dy over dx, just dx is a differential. There should be a period there. It's an independent variable that may be assigned any value. So if I want to travel 1.7 units along the x-axis, then I could say that dx is 1.7. That would be the value I assign to dx. It's a number. Now together we already know that dy over dx means a derivative. It means the slope of the tangent line. What we're doing in this lesson is taking them away from each other and we're studying them independently. What does just dy mean if you didn't have dx on the bottom? It means a change in y that happens as you move along the tangent line. But if you study just dx, it's an independent variable that may be assigned any value. Together they still mean dy dx still means derivative or slope of tangent line, but independently they have meanings. That's what this lesson is all about. So put a big star by this formula. It's on your study sheet. It's one of the two formulas in this section that you need to know. It's the formula for dy. Now, what did we just get through saying that dy is in 2 words? Okay, before that part, what did we say it was? It's a differential, isn't it? Just dy. It's a differential. So the formula to get dy is f prime of x. What does that mean? Derivative. So you're going to find the derivative. And you're going to multiply it by dx. That's the formula for dy. Sometimes the book calls it df because isn't y and f of x? Y is a function of x. So if you see df, it means dy. Same thing. All right, now if you wanted to create that formula, say you forget it for some reason, it's not a very long formula, so it won't be that hard to remember. But let's say you want to see where it comes from. Is that true or false? dy dx equals f prime of x. Does that mean the same thing as that? It means the derivative, doesn't it? Back there, way back in early chapter 3, somewhere you've got derivative notations, and you've got that one, and you've got that one, you've got y prime, you've got all these others. You probably got that one somewhere that I said that our book doesn't use a lot. So those are equal. So how could we get this formula starting with this equation? What could we do to that to make it look like that? Right, multiply it by dx, both sides. Multiply this side by dx, multiply this side by dx, those cancels, dy equals f prime of x dx. That's it, isn't it? So that's really where that dy formula came from. It's just separating these from one another and not thinking of them as the slope of the tangent line, but thinking of that just as a differential. But you need to know that formula. It's very, 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 very important. Now let's try working a problem with that formula before we look at our second formula. Let's do example 4 on page 204. I'll just give you a preview of why this formula is so important. When we get to the end of Calculus 1, and I would dare say every day of Calculus 2, you're going to be finding a du. And in Calculus 1 at the end of our semester this summer, and in Calculus 2 every day, this is what du equals. du is f prime of x dx, just like dy is f prime of x dx. We're just going to have a different letter. So we're going to be doing that probably every day in Calculus 2 for those of you that need that class. So that's why that formula is one you've got to know. Example 4, y equals x to the 5th plus 37x. A part says find dy. And then B part gives us some numbers to substitute in. Alright, for A part, we're going to find dy, but let's write the formula first. The formula for dy is f prime of x dx. When I'm grading these tests that we're going to have either next week or the next, and on the short answer problems, I have write the formula for dy. Well, if somebody misses that one, then I know that when I get over to the problems and they got to find dy and it's an equate, something to work out, I know that's not going to happen. If they don't know the formula on short answer, they're not going to get the math right later. So we got to know the formula first. So we want the derivative of this stuff. So group 4, what's the derivative of this stuff? 5x to the 4th plus what? 37, good. And whatever you get for f prime of x, you're going to put it in parentheses. So get your highlighter out, your red pen, whatever you use to make things look important in your notebook, and put parentheses in red. Times dx. That is the answer to A part. The derivative times dx. If you leave out the parentheses, guess what you only multiplied by dx? The 37. You never got your 5x to the 4th to multiply times dx, so you missed it. B part of example 4. Put these numbers in and see what you get. It says to find dy when x is 1. That just means you're starting at 1 on the graph. Whatever your graph looks like, you're going to start at 1. And you're going to move a total of 0.2 units to the right. dx is 0.2. So you're not going very far, are you? If you went 0.2 of an inch or a foot from where your feet are right now, you wouldn't go very far. It'd be an increment. It'd be a tiny little amount. So I'm going to go down here to my answer for dy, and I'm going to substitute in that for x and that for dx. So I'm going to get 5 times x, which is 1, according to my problem, to the 4th. I made it easy on us on this one, didn't I? Because I could have used something besides 1, but 1's pretty easy to work with. Plus 37. Again, all that's got to be in parentheses or brackets or whatever you're using. Times dx, and dx is 0.2. 0 in front. Okay, so we just got a bunch of numbers, right? 1 to the 4th is 1, times 5 is 5. So I've got 5 plus 37, so that's 42 times 0.2. 42 times 0.2, 8.4. So that's a numerical value for dy. So that's the formula, and that's the number that ties to it based on these given numbers. You may have a question about how to find dy formula or how to find dy value. Okay? Dx is equal to delta x. Anywhere you see a dx, you could just use a delta x. Anywhere you see a delta x, you can use a dx. Sometimes the problem will tell you what delta x is, but you need to know what dx is. Well, guess what? You know what it is because it's the same as that. Sometimes the problem will tell you what dx is, but you need delta x, so you use whatever that is, right, for that, because they're exactly the same. Now, in your book, you've got a very good diagram on page 205. Put a star by that figure. Let me pull it up on the Elmo here. I want you to pencil in something that's not in your book's diagram. Graph of our function in blue, y equals f of x. Here is a certain x value. I'm going to call that x and put it right underneath A in the book. X equals 1 from the last example. About 1 unit over the tangent line. Here, travel. Now, equal to what? 0.2, right? So we're going to pretend this is 0.2 spaces, okay? This tangent line, the distance from here to the tangent line is at the end of all this junk, I want you to write dy. Delta L, we're going to call it dy. Dy from your change dx unit, and it's the change along the tangent line. So that's dy. Distance from here to here. When all the actual, then we would include the dribble that from here to here, right? And this would be a little y that we y to dy. And so this total distance from here to here is delta y. Now, if you're in this particular problem, y more or less than dy. This time, whatever is more than that. Right here, dx is. Dx is right here. It's that distance from there to right there. So we all agree this is a little the same. It says they're still on our note here that dy is approximately equal to delta y. So they're close, but they're not equal. Now here's why that's important. Next part of the notes, the second and the last formula you need to know in this lesson is the formula for delta y. Before we write the formula for delta y, who remembers the formula for dy? Dy equals f prime of x times dx, right? dy is f prime of x times dx. All right, delta y's formula is f of x plus delta x minus f of x. Delta y is f of x plus delta x minus f of x. Now, where have we seen that before? Almost. If we call those delta x's h's, then isn't this the numerator of something important that we've studied? It's the numerator of the definition of the derivative. Because remember, the definition of the derivative was the limit as h approaches 0 of f of x plus h minus f of x over h. You had to work the problem out the long way, didn't you, on your second test? So that thing right there is that. F of x plus delta x minus f of x. We call delta x h. It's that same thing. So if you kind of having trouble remembering what delta y is, remember the top of that, and that's what it is. That one little change there of variable. That's delta y. Now, sometimes your book right here will call this x a. Remember that diagram? It was the starting place. They called it a, and I called it x. Sometimes they'll call it x0 because it's the starting x, so it's just like the still your beginning, your initial x value. Now, what delta y means in word form. Delta y represents the change in y that occurs as we begin at x and travel along the curve. C-U-R-V-E, capital letters, underlined in red. Until we have moved dx, or what was it equal to dx? Another name for dx? Delta x, right? Units. So from that figure on page 205, delta y meant we stayed on the curve. We stayed on the blue curve. But dy, we were on the red tangent line, weren't we? So you got to know where you are. If you're talking dy, you're on the graph. If you're talking delta y, you are on the graph. If you're talking dy, you are on the tangent line. There's a little bit of a gap of difference in them from the figure. Similar, but not exactly the same. All right, now there are going to be times when we need to know what delta y is, but we can't find it, so we find dy and we settle for it because it's close enough to what we're looking for. That's where dy is useful. It's an approximation for delta y. Now let's try working number 40 on the homework page. Page, I didn't write it down. Somebody look it up and tell me what page that's on. 211? Okay, page 211, thank you. 211, f of x equals a parabola. x0 is -1 and dx is 0.1. So these are our three clues, right? Miss Peacock in the billiard room with the lead pipe, right? These are our three clues. Okay, now we got to solve the mystery. All right, A part. Find delta f, or most of the time I'm going to call it delta y, because y is an f of x, isn't it? Find delta y. I think we're going to have a rainy 4th of July, so you may be indoors doing calculus and playing Clue in your spare time. All right, so if they call it that, we're going to remember it's that, and then, hey, we know our formula for that, don't we? Delta y, well, we don't know as good as maybe dy, but it's f of x plus delta x minus f of x. Okay, so there's the formula. A part, they do give us those values, so we can go ahead and use those. So the values are, for x, what do we say the book would sometimes call it? X0. So here's my x, or my x0. That's my starting value. So I'm going to put -1 in for x. Even though they didn't call it x0, that's still x. Okay, that's x. That goes there. Plus delta x, that's the little change in x. This time it's 0.1. Minus f of 0.1 or 1 or something else. -1? -1, right. Now we just got a bunch of numbers. So we got f, -1 plus 0.1 is -0.9. All right, now we got to substitute -0.9 into the function up here. So it's just like saying, what's f of 7? If it were f of 7, we'd say 2 times 7 squared plus 4 times 7 minus 3. That's how we did that in Math 112, right? We've got kind of a weird x value. It's not 7, but it's still an x. So we're going to put it in for x. So delta y is going to equal 2 times -0.9 squared plus 4 times -0.9 minus a 3. Don't forget it, right? It's part of f of x. So you've got to bring it down even though you're not multiplying it by a -0.9. All right, so what I've got here is this part. Minus whatever I get when I put -1 into f. So now if I put -1 in, I'm going to have 2 times -1 squared plus 4 times -1 minus 3. Well, that's kind of a mess. I don't think I want to do all that on the calculator, because if I put my parentheses in the wrong place in one time, I'll miss it just because of that. So let's do a little bit on paper anyway. We could do this part on the calculator. 2 times -0.9 squared. Plus 4 times -0.9 minus 3. Get an answer for that part, couldn't we? -4.98 is the first chunk. It's everything up to the negative right here. All right, Aunt Sally's still hanging around, isn't she? Square that first, so that's going to be 1 times 2 is 2, minus 4, minus 3, that's -5, times a negative is a +5. So I got delta y equals -4.98 plus 5. So delta y is a positive 0.02. So trying to tie it into page 205 graph, your change in y, if you stay on the curve, is a little tiny 0.02, 200ths. Anybody have a question about A part before we find dy and B part? Okay, dy, got to have her formula. What is it? Oh man, we've already forgotten. Right, f prime of x times dx. F prime of x times dx. D formula, except it'll be a du every day of calculus 2. Alright, so dy equals, well, we got to have a derivative before we'll have anywhere to put that x value. So we need the derivative of f of x. It's going to be 4x plus 4. Inside the red highlighted parentheses times dx. it's not in parentheses, remember the 37, then this only got multiplied by the 37, not the whole kit and caboodle. So now that I found my derivative, I'm going to put my x value in. So x is -1, so I'm going to have 4 times -1, right? That's x0, just like it was here. Plus 4, all that junk times dx, which is 0.1. -4 plus 4 is 0, so 0 times 0.1 is 0. So dy is 0. So the change along the tangent line is 0. There's no change. The change, if you stay on the curve, is 0.02. So aren't those two answers close to each other? Wavy equal sign, right? They're not exactly the same, but they're close. C part, find the approximate or approximation error. That's the easiest part. Find the approximation error. The way you do that is you subtract your two answers. You can find df minus delta f, or you can find delta f minus df. Either way, you've got to put them in absolute value bars because you really don't care which one's larger. You just want to know how far apart they are. Now, what do these f's also mean? dy, right? So dy minus delta y. All right, let's just do the first one. dy, what was dy? 0. Minus, what was delta y's answer? 0.02, okay. So 0 minus 0.02 is a -0.02, but it's in absolute value bars, so I got to make it positive. So 0.02. Or if I did it the other way, I'd have my 0.02 first, minus my 0. And that's positive 0.02, and the absolute value of positive is still positive. So you don't have to do it both ways, just whichever way's better for you. This one right here. All right, now then we've got to decide which one of these two answers is the true change in y as x is changing from -1 to -0.9. X moved over 1/10 of a space, didn't it? On this graph, we started at -1. We moved to the right 1/10 of a space. So now x is at -0.9. So which one of these answers, 0.02 or 0, is the true change in the function y as x is changing from here to -0.9? Which one of these is the true change on the curve? Which one is the change along the actual curve, the true change in y? Delta y is the true one, isn't it? Because delta y, remember, meant that we were staying on the curve itself. So delta y is the true change in y as we move along the curve. So why don't we just always find delta y if it's the true change? Why don't we even bother with dy? But sometimes you can't find delta y. So you have to use dy for your approximation. So delta y, true change, dy, approximate change. Or we could say it's an estimate. So just mark that out and write estimate of the change. If we write approximate, we might get that mixed up with part C of the directions, which says find the approximation error. Okay, now let's do one that's a little different. On page 211, number 46. I think they give us the formula on this one too. Maybe we have to remember it. Now they give us the formula. Directions say write a differential formula. Okay? When they say differential formula, they're talking about dy. Write a dy or d whatever your letter is formula that estimates the given change in volume or surface area. 46 is the change in the volume V equals x cubed of a cube when the edge lengths change from x0 to x0 plus dx. Alright, let's picture a cube for a minute. I don't have a cube. We're going to pretend my box is a cube. We're going to pretend it's equal on all sides, okay? Use your imagination. So the volume of that cube is one side times another side times what else? The other side, right? Which would be this side. So pretending they're all the same, it wouldn't matter which one you use, you just cube it. It's a cube. X times x times x. Here it would be length times width times height because mine have different values. So there's my formula for V. Now, when it asks for a differential formula, it's asking for, in this case, a dV instead of dy because we got V's instead of Y's. Normally we'd have Y equals to here we got V. Alright, so we got to remember then the formula for dy. Dy, remember, was f prime of x dx. Dy f prime of x dx. So we need the derivative because this says find the derivative. So what's the derivative of x cubed? 3x squared times what? Dx. And 3x squared is together already, so you don't have to put parentheses around it. But if you want to be super cautious, you can. It wouldn't hurt anything. Just not required here. Now here's what the book's answer will be. The book is going to have subscripts on x. So the book's going to say something like dv equals 3x0 squared dx. So that's just an x here is okay. But if you see that, I just want you to know where it came from. Again, it's that initial x, and whether we're going to call it a or x or x0. Last problem of the day, number 48. I want you to try this one. S equals pi r square root of r squared plus h squared. We'll see what's changing on this one. It says the change in the lateral surface area S of a right circular cone when the radius changes from r0 to r0 plus dr and the height does not change. Underline that in your book. R changes, but height does not change. What do we call things that do not change in calculus? Constants. Constant's the same, isn't it? H is a constant, so you've got to picture in your mind a number there for that. I wouldn't make it a number, but think number when you see it. I'm going to give you a hint. I'm going to do that first. And your other hint is your dy formula. You're going to find, need more room, you're going to find ds. You want to find the derivative of this, and you want to multiply it by dx, or d, whatever your letter is. Okay, I'll give you a 1 minute head start while I write the assignment on the board, and then we'll check it and see if you got it right. You can be nosy and see what the person decided you got on their paper if you get stuck. All right, let's see if you got it right. So ds is what we would use instead of dy. We need the derivative of this junk. R is changing and h is a constant. Now, if R is changing, R is my variable, so I've got a pi r times some stuff in here that has an R, so I've got to use the product rule. Just like Group 4 did on the board on their number 23. They had the products of x's and x's. So we've got the invisible dot with a variable here and a variable here. H, I don't care about h, it's a constant. So the first times the derivative of the second, that derivative of the outside would be a 1/2 Garbola, subtract 1, get a negative 1/2. Times the derivative of the inside would be a 2r plus 0. That's a constant. It does not change. It means it's a number for all intents and purposes. So there's 1d2 plus the second times the derivative of pi r, which is just a pi. So everything I've got so far is this part. It's the derivative with the product rule. And then all of that Garbola's got to be times a what? dx, the end. Okay, now let's fix this up a little bit. Now the next step or two are algebra steps. I've got 2's that'll cancel. R's times r will be a pi r squared out front, so pi r squared. This is going to move to the bottom because it's got a negative exponent. So on the bottom it's going to be a r squared plus h squared under a square root plus pi. This is not going to move because it's got a positive exponent. All of that's times dx. Now that's the way I would leave it. Let's see how the book left it. That's the way the book left it too. Not dx. Not dx. We don't have an x, we got an r times dr. Formula's got a dx, but we don't have an x. We've got an r for our variable, so we need a dr right there. That was a little more complicated because of the product rule. Okay, the assignment is on the board. The assignment is the group problems. All of those are from the derivatives of the inverse trig things that you worked on with your group earlier. So some of them may even be some of those you did together, I don't remember. We're going to have a pencil paper quiz on the derivatives of those 3 inverse trig functions. See if you know your 3 formulas. 3.9 is due. We did all that today. And I want you to try part 1 of the practice test, you know, the handout. I want you to do the book problems, there aren't very many, and then do the My Math Lab part of it at least one time by Monday, see how you do on it. Part 2, we're not quite through the notes on 311 yet. Now I'm going to set up 311 homework so you can get to it, but now don't try to do it all because we haven't done the whole lesson. Don't think you're supposed to. I'm going to set the date for this for Wednesday. If you want to go ahead and do the ones like we did in class today, notes, you can do that. Or you can just wait and do it all after Monday's lesson and finish it up. So what we're going to do Monday is finish 311 and start on the next thing, which is not going to be on the test. Then we'll need to decide Monday if we want to have the test Wednesday or if we want to wait and do it the next Monday. Do it either way. We didn't finish 311 today, so we'll do that Monday and then decide and we'll vote. So we're going to be influencing your neighbor to vote like you. Tell them you know what's best for the class, and then we'll have a vote and the majority will win on Monday, okay? So if you're afraid the majority is going to vote for Wednesday, you might want to go ahead and do part 2 of the practice test too and get ready for that.